Natural selection stops the evolution of male attractiveness. Sexual selection is natural selection where one sex prefers certain characteristics in individuals of the other sex. It has been proven to create phenotypic diversity and genetic variation among species more than non-sexual traits that are selected for. However, sexually selected traits may be subject to an evolutionary limit in nature. Manipulating male traits in respect to evolution provides a way to determine the strength of natural selection that opposes evolution by male sexually selected traits. The proposal of an evolutionary limit on selection for male attractiveness was tested in Drosophila serrata by Emma Hine, Katrina McGuigan, and Mark W. Blows. D. serrata females choose male partners based on 8 male cuticular hydrocarbons, or CHCs. These CHCs act as contact pheromones. Sexual selection by the female's choice causes the male CHCs to evolve in experimental populations. 2 different combinations of the 8 CHCs were tested with an artificial index selection. The first combination represented the CHC combination preferred by females in this D. serrata population, represented as ISS. To contrast evolutionary consequences of selecting for the trait that females prefer, a second combination of CHCs was chosen but tested under weak sexual selection. This CHC combination was represented as IWS. After 10 generations of artificial selection, 2 replicate lines for each trait combination became consistent in response to the selection. The IWS trait combination responded greater to selection, which was consistent with its higher heritability in the original population. Individual CHCs evolved in the direction of selection for all CHCs in both of the IWS lines, while fewer than half of the individual CHCs evolved in the same direction as the ISS lines. This result was expected because of the genetic constraint on ISS. The magnitude of the response in one CHC was also greater in the IWS than the ISS lines for 7 of the 8 traits. To decide if selecting in the direction of female preference did indeed affect male mating success, male flies from the forced selection and 2 control lines were to undergo competitive mating trials with male flies from the original population. Male flies from the ISS lines had much greater mating success than the IWS and control lines. However, the response to selection of the ISS treatment plateaued eventually, reaching an evolutionary limit after 7 generations. While no limit seemed apparent for the IWS trait combination, an animal model approach was implemented to see if a decrease in genetic variance during selection explained the evolutionary limit reached by ISS. The result of the test, however, indicated that a decrease in genetic variance was not the cause of the limit, because genetic variance increased as selection went on. Opposing natural selection was determined to be the most likely cause of the plateau after excluding a lack of genetic variance and overdominance of a major gene from the equation. Overall, the experiment provides evidence that selection of male traits based on female preference maintained a high male mating success compared to control lines or trait combinations not preferred by females. The alleles resulting in higher male mating success also resulted in a high fitness cost, stopping further evolution of the male traits. This is due to a lack of genetic variation. Over a long period of time, divergence in these male sexual traits across 9 populations of D. serrata has been considered to occur mostly in the direction of greatest genetic variance rather than in the direction of sexual selection.